Yeah, I already have this prepared, so why not use it? Okay, I have a problem. I don't have 220 microfarads that I used here on this point. I'm having this 330 and this 100. And I'm thinking to test them actually in the circuit that I'm having there, and it should be good enough. This 330, I'm curious. So this is 330. Let's see how it's behaving here in the circuit. So on pin 7 to ground. Yeah, the needle is doing like that, literally. Let me show you. Well, when it's in this position, is having a very large movement. Let me actually film it from this angle. So let's see. You see how much is doing it? Very, very nice. Very cool. Yeah, but here at the end, I like this large amount of traveling, but at the end is not fast enough. It's kind of, yeah, you see, it's beeping too loud, too long. So I will change this 300 with the 150. Yeah, it's a compromise between how long is moving and how fast is moving. These are all scrapped components, these bigger ones. I didn't buy them. I scrapped them from various miscellaneous boards. All right. It's very nice because it's actually showing that's positive there. I hope you can see anything, but that band is positive for this SMD components, which is totally wrong and bullshit. It should have been negative, like any other components, like the diodes markings, or even the normal capacitor. They have, the true hole capacitors. They have this marking on negative, but they decided to put it on positive because they are smarter than everybody. Idiots. Yeah, it's a bit too fast, and the needle is not moving as I wanted. Let me try the other version. All right, so this is good, but not really. 150. Let's see if I will put two in parallel. This 100. A 200. Yeah, this should be good enough. And I can add even another one to calibrate it even smaller than that, like a 20 microfarads, to get it as close as possible to this one, because this one gave me the best results, this 220. But yeah, two in parallel is good enough. Yeah, I really like at the end this creaking, like very good. And only when I'm touching the wire is beeping without cracking. You can. Yeah, it's very good. This is good. And the movement is very good as well. Yeah, 200 from two guys there. So this circuit is very, very picky at the components that you are using, especially certain components. This capacitor here, and that one as well for the gate. All these here are scrapped, but the rest of them are brand new. I actually bought them, 100 pieces for each. These are scrapped also, this is 33. Yeah, but these are brand new and also scrapped. They are mingled together. And this is 10 micro, brand new, all of them, and so on and so forth. I hope you like my collection. Those are also brand new, these ones, but these black ones are scrapped. Yeah, I really like the cracking, very nice. So two of those for that one. Here 100 nano is no problem. This capacitor here is for the stability of the chip, and I'm always adding it there to get a very good performance and not disturbance bullshit. I already have this board that I mounted this 555 on it some time ago, and I will use it because it is already prepared. And I'm looking at the numbers. It's having tiny little bit of numbers, 1, 2, 3, 4. These are the pin numbers. So I'll have to mount it like this, in this position, to get the chip pin out. And this is pin 8, this is pin 4, pin 1, pin 5, like that. It's a bit weird, but it's good enough. It's good. I will have to actually put everything here. So this is called pre-position. Well, pre-mounting. And my very, very shitty pink resistor box, 10 kilo here. And these are the components that I'll actually use in the circuit. Exactly these ones that I'm making the circuit for them, specifically for them. And 1 kilo there. And this one, 100 nano. These are also scrapped, and they are small enough, and I can use one. Yeah, why not? It's also having these long legs that will add, it will help for the negative line. This transistor is not 702, it's a burned transistor, and this one as well, but I will use them for the making of the board, and I will probably replace them when I will create the actual board. 1 kilo there, and this not gate, probably like that. I'm not sure how to mount it. I should probably make a 3D sketch for all this, probably like that, to be easy to see everything. That capacitor there, 100 nano and 100 nano. So I will probably use this 100 nano here, and the LED. Actually, this is not 200. I just copied that resistor from there. This is 1 kilo to 10 kilo here for the LED, and here I use 5 kilo. That's odd. What color should I put here? Some used components. Let's see, what scrap shit do I have here? I'm having this one with the resistor on it. So I already have an LED with a resistor. I probably, yeah, it's 10 kilo, I believe. So that's my negative because I can see the green mark on it. Let's see what color. Probably it's a yellow one, like this. Green. Okay. Yeah, very nice. Okay. Okay, it will have a green LED here. This motherfucker active buzzer. So, oh yeah, I remembered. I have this passive buzzers as well, and also active buzzers and passive buzzers, and they screwed me because I didn't know about this little detail, and I had to make its driver specifically, and I was thinking actually to implement this passive buzzer with driver, a 555 driver on it. Here, look how beautiful it's looking. And I also leave the circuit diagram here. Also, it's having a LED on top of it already, and I'm thinking to actually use this. So it is having already that LED there. It will occupy a lot of space, but it's no problem. It's no problem because I have space here at home. I'm thinking active buzzer. Let's put a new one. This will remain for the next one, for the next project. Let me actually test it. The legs are not long enough, so this is pretty big. I really wish I could find some SMD active buzzers like this one, so to be small enough, you know. That 200, probably I will use exactly this resistor that I'm already having it here, and I will not change it. I will leave it as it is. And yeah, that's it. I'm actually thinking if I should use SMDs like I started to use them here, or to use through-hole components because I have a lot of them, and I want to get rid of them. And it will look old style, you know. I'm thinking. All right, and I changed my mind. I will use through-hole components because I have a lot of them, and there's no problem of space. This is large enough to accommodate a larger board with larger components, and in the same time it will look very retro. With the SMD on it, it will look like it's made in 2024. But with the through-hole components that I also scrapped from everywhere, and I have a ton of them. Well, a ton. I have too many that I can peacefully get rid of, and I will use this chip after all. This one because it's small size, and most probably this 555 because it's big enough but small enough in the same time, and this buzzer, big buzzer, and this stupid large and big LED, it will be very scary. This is a very nice red, a very sharp red. The problem is they are super sensitive, very sensitive LEDs. I burned a couple of them just like that until I learned they are very special in sensitivity, in current sensitivity. I don't know exactly how they are made, but I learned the hard way. Not many, I have quite a few of them, but let me gather the components again. With this occasion I will show you all my, this is not all my resistors, but this is a part of them. And what do I have here? 10 kilo, which is this. I made all of this, by the way, by hand. And these are matchstick boxes. Transgate means somebody here in Romania. But I really like the very large size of it. They are smaller in height than this. This is high. The size of it is very good. And I also keep here brand new and scrapped altogether. So 10 kilo. Scrapped 10 kilo actually. You look good enough. Okay. So that 10 kilo there. I also have a ton of capacitors, electrolytic capacitors that I took out from boards. And here is how I'm keeping them. I hope you can see it. how it's looking. Let me put this aside. And it's beeping. It doesn't like it. So 220 there. This is how I'm keeping everything. And I also have a small, you see, a small label there for everything to quickly see inside what values they are. But usually I'm looking on the top there. So 220. I have these very big ones, a ton of them, which I don't like. So I need a relatively small one. Very scrapped, but good enough. 220. Good. Very small legs. Perfect for what I need here. And I have no idea if it's good or bad. Nothing is popped out there. Yeah, very, very scrapped. Perfect for the job. By the way, let's see the voltage. 16 volts. Yeah, good. I rarely, very rarely use these electrolytic capacitors. And when I catch an occasion to use them, I'm very glad actually to find a project to use this scrapped electrolytic. So I have a perfect candidate here. Not those two together. And 1 kilo there. So let's see, 1 kilo. Yeah, this is longer than usual, so I'll use you. You are too long. You see, compared with the normal one, is a little bit longer. Probably it's having a bit more wattage, but here is not a problem from my point of view. I just want to use them to get rid of them in my circuits, of course. So this is for the 555. Let me actually put everything. I will build my circuit here on this paper first, and then I will find the proper cardboard for it. So this will come from this pin here, from this pin, and this will stay probably there, and this one across it, very close to it. And that's it, this part, this side. Let me push it a little bit more like that. And this 100 nano, I have a label for each of my drawers. 100 nano, the wicked one. Usually these are high voltage, these brown ones. High voltage like for 220 volts or 100 volts even. This is 600, is written there, 630 volts. So these are for usually for 220 volts or around 300 maybe. I'm looking for a weird one. Oh, this one is good enough. So 100, and I believe I need there another one. Yeah, these two guys. Weird brothers. Very weird notation, 1Z, 1Z. And this, it will need a resistor here. A 10 kilo to be sure. A quite long one. Again, I have this longer resistors scrapped. This is how they are comparing with this normal one. You see, it's a bit tiny longer. And I don't like them because they are so long. So I will get rid of them. So this is for the LED, this and this. And that transistor I'm thinking, because I'm having deep through-hole version as well for this transistor, that I never use them. These are all scrapped here, NPNs. Everything I'm having here is scrapped. Nothing is brand new here. Although I put them in bags, I label them, that's why. I'm thinking maybe to add this Russian transistor. Yeah, that one. Well, this no-name one with a green spot on it. Or even this longer fucked up 373 F2. No, you know what? I will use a standard resistor. I don't know what this is. So these are very weird names. I never use them. I never find them. And I will use a standard pinout. A standard pinout for me, at least, is like a BC548. This is the standard pinout. Collector base emitter, not bullshit. And I will choose something else from here until I will find. Probably, you know what? This kind of transistor also have standard from my point of view, of course. Pinout. BC107. BC107, it's a classic transistor. Let's see if, and it's also adding a very retro look on the circuit board, you know, in the end, with this metal case type of transistors. So this will be there, and it needs 1 kilo. 1 kilo. If this is 1 kilo, I will shoot in my balls. Look, the markings is brown, brown, black, brown, brown. This is 1 kilo. This is how 1 kilo should be. Brown, black, and red. Not brown, brown, black, brown, brown. What the fuck? And is also true for these ones as well. This is brown, brown, black, black, brown. So they are inventing new barcodes. They are just idiots. Those who are making this new 1% resistors. They are literally idiots. They want to screw up the normal markings, color code of the normal resistors. That it's so good. It's so good. You remember it very, very quickly, and it's very easy to follow, to understand it, and to remember it. So I have a bone against those idiots, because they are idiots. Pardon my French. So I will use this one. It's very military looking, very green. And probably I will change more of these along the way. Depends. Or put this another long one. Yeah, another long one. Long and stupid. I don't like them. but I have a bunch, not many, and this is a good project to use them all. So my transistor, this one, is somewhere here with the resistor like that. So right now when I'm making it here, I'm actually planting my components, and after I finish building everything, I will see how big the cardboard will have to be. So this is a pre-testing. And here, this one will be a semi-day probably. I'll have this semi-day. This is a burnt one, but it will be on a board, on this prototyping board that I made them, specific for transistors, for SMD transistors, and it will be there, you see? And this will be the board for it, to hold it, like that. But this is burnt. I can play with it. So this is this here. So this position will be somewhere probably there. Probably I can rotate it like this. So drain, and source here. So zack, and this is the, okay, this will be the orientation, how I will mount it. And this guy here probably somewhere there. This one will actually make the connection from there, from that point to something else there. This transistor will occupy quite a lot of space there, so it will be in this orientation actually. So I'm having this half of the circuit already made. So this guy, this LED, this motherfucker LED, should I use something else? Because I'm having this one. That's why I can permit to put, yeah, probably, you know what, I'll make them one side by side. They are pretty much the same dimension. I will not bend the legs yet, because I will have to see in the circuit how I will mount it. So I'll leave it with the legs. So these two will be one near each other, and this is the resistor for this. So it will be something like this entire circuit long. So it will be a bit longer than this device, which sucks a little bit. It's okay, it will be probably underneath it. I have no idea how to mount it and where to mount it. By the way, this is the label on it, from 2 to 10 milliamps when it was brand new, but after I repaired it, because it was disastrous inside. Made in Romania is actually saying they're made, and the year is 1987. 1987. Wow. In the communist era, and they actually use this in English here, made in Romania, not făcut in Romania. Very interesting. And tip, I don't, this is an acronym for something. IAM, I don't know what that means. Yeah, okay. So I was comparing the size of this and where I will put this entire board. Probably this entire board will be on the top here. I have no idea how to mount it. I was thinking actually like a pistol grip, you know, with this one, because it's looking very funky with this metal shape here. And the circuit, I don't know. I really don't know where to put the circuit here, but it's occupying too much space. This is a very big problem, very big problem. I'm very inclined to put it underneath it here, so it will protrude. It will be a little bit longer until here, probably. Yeah, it's good enough. It's good enough. And everything, all the components will face down, and probably I will make another box. They will stay inside the box, and only the buzzer and the LED will stay here on this other side, and probably even heighten. So I will have this like this, higher, and also the buzzer higher, and also inclined in this position. So I will have to incline them. Yeah, it will look cute. It will look cute, and this like this. Will be the buzzer and the LED. This big stupid LED, big and stupid. Yeah, and probably then if I will drag these two components from the board here on top, they will be outside. So I can make them. Let's see. No, I don't want to obstruct here. This. I'm thinking. Yeah. This is very big and very stupid. Like that, something like that. I just put it in one hole there, and this buzzer here, so I can move around these two components because they are big enough, and you know, yeah, why not to put them here in the front. So I considerably, and also this resistor for the LED will get there somewhere around along the track. So the board is much more smaller right now, which is perfect. This is perfect for the size of this device, and I can squeeze even more, and this is how the width it will be. Yeah, it will fit probably here in the middle, like that. Huh, interesting. Okay, nice. This LED, how big it is, it is quite funny. It's very funny, like that. And yeah, I'm thinking. So I need this capacitor here for that position there, for there. And also I will have to add positive and negative pads. So I have to account for that. So probably this will not be exactly this size, or I can make it more wider. This is perfect actually. This is perfect. I didn't plan for this. I just took it out from my box of cardboard. So this is quite good enough here. Yeah, I can cut it now, and I will fit everything on it. So I will do it like this, like that. Actually, I can cut it to get it into the shape already. It's not a big deal. Yeah, it's probably not, I didn't center it perfectly there, but it's good enough. Yeah, nice, very nice. So this will be the cardboard that components will stay onto. It's very on the limit here, very on the limit. Okay, I will trim it later if it will need. And the thing is how I will catch it here, only by gluing probably. And this will actually be a box here. Okay, I put the rock and roller back again. By the way, this circuit is running fine without this element here. So as you can see, come on, like that. My finger was underneath it and it was sensing it. So if I'm doing this, you see, it is still working fine without this coil meter. So that coil meter is not interfering at all, which is a very good news. It's a good thing. So even if this is broken, it will work fine without it. So yes, this is how I'm planning everything. Yeah, cardboard. Cardboard is the new technology. My invention, by the way, I didn't see it anywhere. Nobody is making on cardboard like I'm doing it. So I'm, in a sense, I am promoting it. It's the cheapest way of making any circuit boards and to test them. And it's very good. It's a very good idea that I had a long time ago when I was very young, actually. Adolescent or even younger. Okay, so this is the plan here. So it is taking a little bit of time to play around, to choose your components, what you are using. And because this is, you see, because they are like this long, I have plenty of space here and here to add pads for the rails. Positive and negative probably rails or something like that. Or just large pads for connecting everything. I will also need pads for these wires and for the LED wires, so separate pads. So it will need extra room here. So it will sit here underneath it, facing this way. And all the displays will be very visible here in front. This LED, this buzzer, and the dialing coil. Yeah, it's good that I changed my mind, because I could feel I can fit all this larger, and probably I can use even larger 220 microfarads than this one, because I have larger ones that they are occupying a lot of space. But if the capacitor is larger, the diameter will be bigger, so I will have the box underneath will be as big as that capacitor, or I can make a hole specific for that capacitor to stay out, but I cannot put it on the table. So the box will be as high as that capacitor if I will include a bigger one than this. So this capacitor actually, you know what? This capacitor, I can put it here outside like that and drag some wires from it into the board. For the idea is, in the end, this entire contraption to stay flat like it is staying right now, with all this circuitry underneath it here, encased in a box, of course. So on that box it will stay like that, right? It is clear as mud. I can put this somewhere here, whatever, whatever. Here, even there I can put it probably. So I'm thinking right now, yeah, on the side, somewhere on the side. It doesn't matter where. It can be on the back here. Yeah, it will be cool. And I can use as big capacitor as I want, actually, to get rid of those larger capacitors that I'm having. I am thinking right now. So I'll have to accommodate a larger pads for this capacitor to fit into. Interesting. All right, that's it for this part. I will take a break, and after that I will start to actually film everything how I'm making. So this and this will stay outside. Most probably this one will stay outside. So only these components will stay here on this board. Good to know. Okay, let's start drawing the placement of the components here on the cardboard. Let's see, first of all, the orientation. How do I want it? I believe I wanted it like this, like this. Then here is the ends, and this is the coil here. So they will come here, and this will be the 555 here mounted, and here the coils. Well, I'll include this one as well. $1 kilo here. from 6 to 7. I'm thinking to add this 1 kilo directly here on these two pins. Yeah, perfect, perfect. Okay. Actually, I will solder it right now just to put it out from the equation, or not. Actually, I have a lot of space here. I'm also thinking this capacitor, probably I will include it. What to do? Like that, it will stay there. I'm thinking. I'll put a very large pad here because I have these other connections, and probably I will drag a wire here, so even larger like that. When I'm having too many contacts, like 1, 2, 3, 4, 5, this wire as well. When I'm having too many contacts, it's good to have a very large pad. Okay, this is the positive pin here, actually, and it can be like this, very close. And actually, 5 volts, I can write it. And here, this is negative. We will see where I will drag. This is positive there. Okay. So is this 1 kilo here? And then this 10 kilo. Yeah, it's fitting quite nicely here, like that. A little bit too close to the margin. And here I will have a ton of space, most probably. I should move everything a little bit more, like that. I should have made all of this on a piece of paper and then glue that. Yeah, shit. Well, this resistor I can put it somewhere here, probably on the pins. So I'll make these two pins here for the capacitor. And actually I can make this negative rail, negative pad. And let's see, this 10 kilo, yeah, it's plenty space. So this is ground, this point here. For this, this and this. This is actually pin 7 here. This is pin 7. Okay, it's a bit too agglomerated here. And here probably it will be free as fuck. So this will be the MOSFET, this guy here, and it will stay like this. Here, a small ground pad for that pin and this wire here. So do 2 with 6 and 4 with 8. This is the output. So this is drain, this is gate, source. Actually, I will write them here. It will be connected. The gate will be the antenna. This will be the gate that will get out from the board outside. And the source here will go to this pin or that one. Pretty much on pin 7, you see. This is a wild wire. And this fellow, like I said, I want collector base and emitter, very easy to mount. So it will be like this. So here is collector, yeah, like here, collector, emitter, this is base. See, very classic and very good, an emitter, like that. And actually I will write it here as well, on this other side. It's good practice to have it all around. Okay, so collector will go to output to this pin directly here. And 1 kilo from the base. Okay, and emitter, this will go into that NOT gate, which is this one. And is very, very close to finish. Yeah, it's well spaced. And that's very important, to be very well spaced. And here I'm thinking to either use this chip or the other smaller one, because I have a ton of space. And it will be wasteful to use this larger one. I'm thinking. Well, it's simpler. It's very easy to use this larger one than to use those smaller. 7414, and this is the pin. The first pin is the input, output, and then input. So I can link them together, these two pins. So this pin here, the input, is linked to the emitter here. So a wire that will go like that. Underneath, I will make it underneath. I will make a pointy wire. It means it will go underneath. And also capacitor, and probably I will use this SMD capacitor, or let's see this bigger one. I don't like this bigger one. I can drag some wires from here to here, but it's better with the SMD there. So SMD to the rescue in this particular case. And these two together, this linked underneath, and this, the fourth one here, which is the output. And I will have to drag a wire to this wire here. It will be linked here, and it's plenty of room here. And this other wire is going to positive rail there, to here. Yeah, it's good enough. Let me enlarge this positive pad a little bit more, and probably this one as well enlarged. Okay, this is the drawing part. Pretty much this is the circuit layout so far, and it took me less than 1 hour to lay out it. And next I'll have to actually implement it to put all the pads. I've seen crystals in this shape, like a capacitor, but I know for sure I tested all my capacitors, so I hope I didn't put a crystal oscillator like this. Okay, I will literally glue it here, this and this, there and there, and I can do it now. This is glue for shoes. You can see a shoe here in the picture, and this is a glue that is gluing the shoe to catch. It's very, very good. It's a Prelandez adhesive, and it's also cheap, and it's very professional. It's doing its job very well. Okay, let me put it correctly. I'm looking on the numbers here because that's what I want. Some glue got out through these holes. Shit, that's not good. That is not good. Yeah, it's better now. It will stick like a motherfucker, this glue. It will rip off the layers from this cardboard when it will harden. I didn't put enough. Okay, let's say like this. All right. This is silicone. You see here, silicone, transparent, clear silicone glue, and it's very good at heat. When it's heating up, it's getting, and because I didn't use it for a very long time, it is getting very, very hard now. It's already too hard to push it out. Yeah, it's very hard, very rubbery right now. It cured almost. I should probably take it out from there, and this there. And this will adhere to the cardboard extremely well. And I want it like this. Excellent. Yeah. Trust me, when it is getting cold, is cementing itself there. Only on heat is very, yeah, you see, if I'm pushing it, you see, yeah, it's very, very hard, extremely quickly. That's the name of the game, you know. Ah, fuck. It flew away. It flew away. I cannot find it. Motherfucker. Here I need a little bit more precision because it's the pin of this chip, and I cannot mess around. Is 1 hour and 9 minutes and 23 seconds passed at this point. Perfect, perfectissimo. You see how fast and easy it is to make them. This is a bit more challenging here. I'll have to think about it, and I kind of know the solution. So these are custom shapes that I rarely make them. Usually I'm making square or longer shapes like this. I'm really making those. I'm cleaning the space to be sure, because it's so tiny. I need to be very sure it's cleaned and it's not contacting anything. I can check it with my checker here. Good. If it was making a short, it was beeping, so it's clean. This pad is clean. It's fine. Pretty much this is it for this part with the pads. Okay, now to mount all the components or to glue it here. I'm not sure what to do first. Probably to mount the components, because it will be easier. I have to think a solution of finding a way of catching this better here, not with glue. I'm not completely sure how to proceed. Yeah, well, a little bit of glue, or you know what, with scotch. Yeah, probably scotch will be better for this entire box. And for this outside elements, I will have to drag some wire somehow to link everything. I don't know. I'm not sure yet. Okay, but less talking, more working. Like that. little bit bend to actually insert it inside if I can. So I'm having a little hole there that is catching this capacitor. And here I will have to add a tiny little bit of wire. And if I can do the same trick to actually insert it inside there, so I need it a tiny little bit like that to actually enter inside it. Yeah, kind of, yeah, on the limit. Excellent, excellent. Yeah, it's a bit misaligned, but it's good enough. It's very good. The 10 kilo here, I believe this is one. Usually is not correct, and it's not good to bend it, to bend the resistor quite so close to that little cap that is having. But really, I don't care. I really don't care. But this is a good rule to follow and to understand. It's not a good practice to do it like I'm doing it here. I was a bit too generous here. I need longer legs for this. Shit, actually I have more 10 kilo resistors with longer legs. Actually, you know what? I can bring down a little more this part here. All right, and now it's catching better. Okay, and for the moment I will put this capacitor and then I will think if I will add it somewhere else. But it's an option, you know, it's an open option to mount it outside of the case. If I will change my mind later. It's okay to change your mind, especially when you are building on cardboard. That's the beauty of it. This is the biggest advantage when working on cardboard. You can change stuff along the way. You can cut and change a lot. You know what? You know what? I'm thinking, because I'm having such small legs, I'm thinking to help it a tiny little bit by cutting the cardboard a little bit, to make a little bit of, to press it down into that hole. And that's what I will actually do. So this is a tiny little bit of makeup, what I'm doing here. I made a ton of stupid decisions in my life, so if I need to repair it because of this little hole, I can put another cardboard underneath it. So that's the solution. So right now is a tiny little bit down in that hole, and the legs, and I helped this tiny little bit of legs to reach a little bit better there. If I remember right, little dimple is, this is the emitter, and if I remember right, I didn't work with this type of transistors for a very long time. I'm not even sure if it will do the job properly, but I will change it. If it will be a problem, I can change it. It will be nice to work. This will prove that old components will do just fine. There, excellent, very good. Actually, let me turn it like that. Again, it's not good what I'm doing, but sometimes you need to do it like this. Now I like it. So what I did here, I put it as in the margin as I could here, because here it will be the pin of the transistor that I will put at the very end, because that's the most sensitive element that I will have to deal with and wear the bracelet while I will work with it. But until then I will mount and wire everything else. This is having a tiny little dot there, or point, and it's impossible probably to see it from this distance, but I am looking for it. Actually, I will bend a tiny little bit this leg and this one as well. Okay, and these two pins, I'll get them closer together, not very close, a little bit, not like that. I didn't break it, but I bent it too much. So I made like a V like that. Here, I united those two pins because they are linked together. and it will help me a little bit. It's right on the limit, right on the limit. I'm dealing here with very fine. Good enough. Yeah, good enough. And now these ones. These two ones. Actually, it's very hot. Excellent. Yeah, quite nice, quite nice. And the capacitor between here and here. And this will be the output of this second, the output of the second to the middle, which is those two pins. I actually was thinking to add this one to make a longer legs for it, because I have a ton of space here, but it's a bit tricky. It's possible. I think I know why is a problem, because I have to drag a wire from there to there. But I think I can solve the problem around this pin here somehow. Yeah, if I cannot solve this problem, I'll put this SMD here. Yeah, actually, let me find the solution right now, because I finished adding all the components excepting this MOSFET, very extremely hyper sensitive MOSFET here. So this will be at the very end. So now I'll put a wire from here to here, very special wire it must be. I have pieces of oils. Perfect, perfectissimo. Okay. It only needs a little bit of cleaning at this end. So this is having isolation on it, like that. And I made a little bridge over this leg. I'll put it from here to actually see the wire. That's why I'm leaving a little bit of space between the hole. I was putting before the hole very next to the pin, and I couldn't see the wire. But from here to there, I can see the wire is going into that hole, and I know it will go underneath. And here, the same thing. From here, I leave plenty of room to actually see the wire that is going underneath. Do I need isolation? Yes, I need isolation, because it will pass over those. Probably it's best to put some a layer of protection, a little bit of paper. So my strongest adhesive here. I'm not kidding around. And I need it between that point and this point. So I'll put this here. So this will confer a tiny little bit of protection from shorts, especially when I will heat up these pads to mount something else there, or to change stuff. The heat over that isolation wire that is coming beneath it will melt the protection, and this way is better. I'm having some scrapped wire, and because it's scrapped, I can see actually parts of the wire that are desisolated, that are blackened. So this is not a perfect wire, at least this one. But I have this one. This is perfect. This is having a very good isolation. Yeah, probably is the best. It's best to use this proper one. I'm always leaving a tolerance. It's good to leave it bent like this than straight. If it's straight, it will drag and it will get out. But if it's bent when it's dragging, it will behave like a spring. So it's better to have quite a good tolerance. Very good. I know you cannot see very well from that distance, but it is, I catch it good enough there. So like I was saying, I will bend it and create a spring from it, you know, when all this board is bending, and probably it will bend a tiny little bit. This will not drag the wire too much. Yeah, I'm having a ton of space here. Yeah, I cut it a little bit too long, but it's good enough. All right. Okay, this is good. This is good. I can actually put another piece of paper over this, or I can do it like this. Bend it like an S. It will be more springy this way. All right, and yeah, I like it. I like it so far. Do you like it? Leave a like if you like it. Okay, I will take a little break and then I will come back and I will add more wiring to it. Yeah, for me, it's not fun and it's not hard to do it. It's just I close my mind. I'm entering in that building mode, and it's like dreaming with my eyes open, and I'm concentrated fully on what I'm doing here, and that's what it is for me. But it is not stressful. It's actually the contrary. It's very stress relieving or cathartic. When I'm concentrated on something, I'm distressing. So I'm having an idea to test this circuit with everything like this, and then I will bend everything and mount it. So this will be in air pretty much. And it will not work because I don't have the transistor. Hmm? Yeah. Huh. Yeah, it doesn't have the transistor here, but it appears that is kind of working. And the LED is lighting up. Yeah, I think it's working, even without the transistor. Yeah, this was a very quick test. And I'm not completely sure how good test it is, but it was some sort of test. Actually, let me see if I linked everything correctly. It looks like all the wires are connected correctly. Positive power, the power lines, positive rail and negative rail, looks like they are correct so far. That's pretty much it. This is it for this part. Oh yeah. I'm isolating this end. That's what I did here with a little bit of plastic. All the time I was using this strap. Yeah, okay. You see the distance is quite large right now. Before, with this one, I was getting very close to it to see the effect, but the longer the antenna, the larger the distance. And probably I can add even longer antenna than this. It's not making that buzzing like the other one at the end, probably because of these capacitors. This is not good. Yeah, it's kind of stuck at the 0 point. Huh. Yeah, it's having some issues. It's not perfect. What I highly suspect is the quality of this capacitor. It doesn't need... it is sensing me from that. From here. It's sensing me. Really? Wow, nice. Nice. Okay, this is the antenna here. And okay, so I not necessarily that the capacitor is very new or very good brand. Actually, what I highly suspect is a little bit of usage of the capacitor. That's why I was getting a little bit of crackling noise with this circuit here, like at the end. Very nice effect actually. But here, this is another capacitor that I use, very different from that one, and very different, not as new but as used. Is my highly guess. This is my guess. So probably in the future I will change this capacitor here to get a bit more crackling noise. And also this capacitor here, I believe it matters what kind of capacitor and how used it is, not really how new it is. Probably that will be another factor as well, how new it is. But all these capacitors that I'm using are mostly they are used. When it's beeping in continuously, I don't like it. This is an error from my point of view, and I don't know how to catch it and how to solve it yet. Or this transistor here, probably this is keeping high, is getting into that error. You see? I don't know when it's happening, but when it's happening, it's very annoying. Yeah, it's having. I like the range. Very good, very big range here of sensing. Very good. The longer the antenna, the better. You see, when I'm getting close to this one, it's changing the frequency here. Very nice. Very nice. I like it. So, this. Yeah, very annoying. Very annoying. Is this motherfucker. So I have to change it with something else. Well, no problem. Calibration. This is called calibration. Especially because I'm using this old and used transistors. These are Russian transistors, very old, but good enough. I collected them from miscellaneous boards. To be sure, I will put my strap on. To be sure, I'm not fucking up that sensing transistor. MOSFET. Shit. Well, it's good that I'm having errors, actually. I'm ruling out bad components. And I don't know which is the emitter, which is the collector on these ones. It is having a diode here. But it's very weird, the diode position. Usually it's in this point. Okay, let's see. If I remember right, it was very... No, it's taking a tiny little bit of time to beep. Not good, not nice. Not nice. I'm usually using it for voltage measuring. Let's see if you are better. I can barely hear you. What is going on? Battery is announcing me. The battery is dying. Shit. This is also having a delay, but at least is a little bit better than the other one. So now I'm checking where the fuck is the base. Yeah, I believe this is the base. And some of these, one is collector and one is emitter, but I don't know exactly which is which. So this is not really good for the... I need with the base in the middle. Ah, this one, BC 171, 172. Yeah, no, it's good. It's exactly like a normal. Okay, good. I find it. It's very good that I marked them. That I put this little picture here. Now I can find them very quickly. Scrapped, used, probably a little bit burned. I hope not, but it's definitely stressed. Yeah, actually, you know, is that is the matter. Okay, let's see now if it's doing that funny business. If it's still doing it, yeah, it's still doing it. Super annoying. Yeah, the range changed a bit, I guess. Yeah. Huh, very strange. If I'm getting close to it, very, very strange. Okay then, so here what I'm having here is, shut the fuck up, is BC 548. So I'll put a BC 548 brand new there, just to see if it's changing anything. And if it's not, I'm screwed, because it shouldn't do this thing. Probably it's a wiring problem that is interfering somehow. I'm not very sure. So you see, BC 548, and this is my bag. And I have this bag for a very long time. I actually changed the bag because the plastic got ruptured, and this is ruptured as well. And I have an already tested one. Wow, I don't expect to change, but if it's changing, then it's very picky on the transistors, a certain type of transistors, but I don't expect to be that picky. I expect to have the same problem, and it might be from somewhere else, the problem, but it is activated near this transistor when I'm getting close to it. It's my best guess. Or something is not connected right. I really like the range. Yeah, here again. Shit, something is not correct. Oh, you know what? This was doing exactly the same thing when, like this, when I changed this capacitor, it was staying on all the time. So I bet it's this capacitor here. But I really liked the range with this BC 107. The range was very good here. It was sensing me from this distance, like that. Very good. So now it's doing the same thing. I bet is this capacitor there. Okay, I will put back this BC 107 and I will change that. So it's doing exactly the same, doesn't matter the transistor, like I suspected. But it is coming from him, when I'm getting close to him, is activating the error, the beeping. So it's a bit confusing, but it's good to have a good guess about things. This was having a very nice range, for some reason. Let's check it again, to be sure. It still is. It's fluctuating. It was sensing my... You know, it's getting weird. It was sensing me from a very large distance, actually. You remember? And it was this one that I used. Okay, let me change that capacitor there, because that is probably the most... This motherfucker here. And I'm having that little wire there, which is a bit... this bridge wire. Yeah, good. Okay, yeah, it's a pity. Okay, let me actually try with the SMD capacitor there, because it's easier to use, 100 nano. And I will use a standard one, this kind of capacitor. I mean, I will change with other capacitors probably, but I really hope it will work fine with this one. Let's pray it's good. No, it's not good. Fucking hell. Is this longer wire that I'm having here from the emitter to that input? Probably. Probably, you know what? I have to decouple. So this is the problem. From here to here, this wire probably is too long and is also sensing or something. Or feeding back the signal, I don't know. And now it's more worse than before. I'm thinking to add a capacitor from there, from this input to here. as well. Let's see if I'm lucky. Let's see if I'm lucky. But this is my on the field repairment, you know. Let's hope it will work. But I'm thinking that longer wire that is underneath is adding this erroneous behavior here. And it didn't work with my SMD there. Please work. Are you going nuts? It doesn't seem to going nuts. But the range is not that great. It is exactly as before, and yeah, it's good enough. So that's the trick here. Fucking shit. So if this wire is too long, I hope you can see some shit here. What I'm doing here. So if this wire is too long, you need a capacitor here. It's probably picking some interferences along the path, and this is actually catching the signal and it's transmitting the signal, so it's very sensitive usually. Very interesting. So this is what I did here. I've added this capacitor here. Very interesting. But the range, yeah, the range is not that great. I don't like the range. Now I'm thinking maybe the other transistors were better, but I did get a very nice effect with this bitch. Is peeling off this little paper. It's not great. So this is the distance from here for very slow. Yeah, it's good. I bet a very big wire antenna, a stupid big one, will do a better job. At least double than this one. Yeah, this is kind of double. It's even longer. So I'm putting my strap on, and I'm sure I'm touching very firmly the skin there. So I will change the antenna again. Hopefully I will increase a little bit more the range. The new antenna is mounted, very large, very big, like that. And it's very close to my mains there. I don't like it. Let's hope. I'm getting this, you see, it's a tiny little bit lit up. The LED is lit up, but Come on. What the fuck? Is not maybe it's interrupted? I don't think so. Wow. This wire doesn't like this wire. No, it doesn't like it. Motherfucker. Probably because this is solid core and this is stranded core. Probably. I'm thinking with my mind. Not really. It should have been increased exponentially right now. But it's not. Fuck. Fucking hell. So the antenna wire matters? Really? This is a new thing. If it does. Let's see. This is not that longer than that. Not that longer. You know what? I can put these two together and make it a longer one. And they are both solid core. So someone asked me, how do you manage to be so precise in welding and soldering like I just did here? And my answer is practice with time. How can you be such precise? How can you have such precision? And hopefully I will not fuck it up. Hopefully that transistor is not fucked up. The range. Shut the fuck up. Oh, hold on. Let's make it like this. Oh, nice, like this. Range, very nice. But if I'm getting too close, it will beep like an idiot. Yeah, nice, I like it. So this is called calibration. Let me actually make it very small, this to coil around. I can use another white one. Yeah, I'm having another white one. Just to have them both. Opa! Check this out. I'm having a larger one. Good. So I'll change this with that. So check this out. This little detail I didn't know about antennas. It must be solid core. If it's stranded, it's not good. Wow, I didn't know this. Very interesting. So I can manipulate without my grounding wire here. I can manipulate it because this is isolator here, theoretically. And it will not conduct potential, higher potential. So this is the new antenna here. All right, let's test this one. It should be the same. Okay. Because it's moving, is doing this chirping. Okay, let me coil it, make a coil out of it. This is isolation here, a little bit of isolation. That's good for the ending. So my coil I want to be like this. I hope you've seen anything. So like this I want it to be. Let's see. Not really, eh? Not really. Fucking hell. Then bigger, like this, very big, like this. Huh? O nie, că tot e în gură. Okay. It is still getting that effect, that beeping effect, but not from here. This time it's from somewhere else, probably from the coil itself, the beeping. Yeah, it did enlarge a little bit more. Yeah, good. So that's this is the trick, to make a very big coil here, huh? Like this, and around it. Yeah, good. Yeah, the range is good enough, so it must be large and round. Yeah, like a circle. I'm wondering if I'm catching this other end there, if it will still behave like an antenna. But the range, it increased very, very nicely, like this. Very interesting. Eh? The obscenities of electronics. Man, when they see a circle, they want to penetrate it. Now, after I solve this little shit problem that I had there, the next stage is to actually catch these two elements here outside, and this I have to glue it here and then drag the wires to it. That's it, pretty much. Okay, so let's do that. But I will get rid of the antenna because it's in the way. I made the test, it's working fine, and it is calibrated right now, and it's no problem. So I can put it aside for a while and take out this. This is gluing time. Like this. Look how cute it is. Very nice. I will not glue it all the way. I will put some points of glue here and there. Here, there, probably here in the middle, a little bit. Here. Oh shit! I realize this is metal, and these contacts will make short circuit with this part. So I really need to put a protection cardboard here. Oh shit! Yeah, I didn't see it. Okay, it's good. It's good that I've seen it, but I have to move very quickly. Yeah, I didn't realize it, but I did now. It's good. It's very good that I catch it in time. And not to touch there, because that's a very sensitive element. But I can touch everywhere else to press it, especially here in the middle and in the corners. So the connections underneath this cardboard was making connections here with this metal, making shorts. So this is a protection cardboard here. Very easy, very quick to make. And voila, that's it. Now I can glue it to this. And like I was saying before, I will put strategic points like this. Why? Because if something is wrong, if I really need to take it out easily from those corners. Although this quantity of glue, it will be very, very hard to take it out. All right. Quite nice. Do you agree? Do you agree it is quite nice? Let me actually change these original wires with something that will fit the length to my circuit board here. Yeah, like this. Very nice. Very cool. I made this tool for exactly for this event. Let me show you on this one. So this is for desisolating. I created it, as you can see. It was a screwdriver here, and or screw end, very wide, and it broken, and I polished it. I put it on my polish wheel, and I grinded it in this shape, and it's catching. You see, I'm very used to it. Actually, it is the oldest and the best tool that I had for desisolating, but not for many times. Just, and I can desisolate very fine. You see, very fine ends with it, like that. So I'm catching it on this other side, and I'm dragging from the other, and this is how it's desisolating it. Very good. That is sharp enough between those two cuts. So this is my invention here. I hope is helping someone out there. I have to desisolate this wire actually, and I can have quite good level of how much desisolation I want to get rid of. It's very precise in a way, but you have to get used to it. That's the problem. So I am very proud of it. Okay, good. Here I can put a little bit of scotch probably, and this guy here is here actually. Huh, how convenient. Here it is sketched. Yeah, at the output of the second. No, in the middle. Here this is the coil, and is in the middle here, which is that point there. Well, I can do this. Alright, I didn't plan for this, but is doing a great job in this position. And it's under, is this little wire here that is bent, and this is under it. So this is going there, and here the wire. Okay, let's see if this wire is long enough. It appears to be long enough. Good. This is the original wire actually. Let's see if it's long enough from this side. Huh. Okay, let's try it. Good. I like it. To cut it a little bit, this one. Like that. Yeah, good enough. And now it's holding there better. I like this too. I like it. And now the hardest part actually is mounting this and this somewhere here. Ideally is to use these two holes for both of them, but at least here I can use this hole, but there is impossible. I didn't think on this too much. Then I will drag the wires like that somehow. Yeah, I have no idea how to mount this, but they are staying nice together, one near each other. So let's make this through hole. Is near this ground. This LED is contacting the ground. Yes, here it is. So it's good that it's there, but I will have to drag a wire somewhere there. You know what? I can enlarge. Yeah. I can make this. Ta-da! You know, and I make some room there, a tiny little bit room, and the legs of the LED I can move them through those holes. This 1 kilo will be a problem probably, and that's why it's good to keep the legs intact. Who knows when when you will need these long legs, like in this situation right now. See, it's very good I didn't cut them. I didn't think I will need them. I was very sure I will cut them at some point, but turns out. So let's see. I want plus here, plus here, a negative here. So like this. I hope I can move them through those two tiny holes. You know what? I don't think so. I don't think so. No, I have no chance. But it will be cool. Okay, then enlarge them a little bit. Because they must be too tiny. Let's see now. Actually, let me check from this side. Yeah. Come on, baby. Huh? Yeah. So that did it. All right. A little bit of larger holes. And here doesn't matter the resistor if it's on this side or this side of the LED. So what I'm thinking is to link this ground pin here, and from this positive to add the resistor, from this positive leg to add the resistor and the wire to there, because this is very close to this ground line. That's why I can mount it very quickly here. I put a lot of solder there to be sure. So this LED will not go anywhere from here. It's very stable. And this is a problem here. And so this is my idea, to put the resistor here and drag the wire there. But how? Only with some isolation here. And I don't know how to isolate it there. Actually, I know. I have this tube. I want to show the resistor value, so I cut it very close. I'm only covering the leg length pretty much, and this will not go anywhere probably. Hopefully. I can do this, especially here on the end. And now it will not go anywhere. That's it. It's secured there. So theoretically now I can bend it anywhere I like without being afraid of shorting anything. I didn't plan for this at all. I didn't design it to be this way. And this should get in the middle, which is here. I can do this. I can drag this isolation right on the margin here. And this point I will solder it there. Very, very tricky. Very tricky. I'll probably have to get rid of this resistor and drag a line from there here to help everything a little bit better. Or across it like this. I have no idea. Although I have a ton of space here, specifically destined for these connections that I'm making right now, and it's still not enough. Probably like this. And I have to pray not to make contact with the other side. No, I don't like it. I do not like it because I don't trust anything that I cannot see. Or like this, maybe. Yeah, this should do it. This should do it because I can see what is going on there. And here also a little bit of protection. This is not rubbery anymore. This is plastified, cemented, but it's perfect for what I need here. Even more, motherfucker. Yeah, this is it. I can barely see what is going on there. Actually, you know what? I can always put a little bit of plastic, melt some plastic over it, and problem solved, you know. Let's see if this is doing the trick that I wanted to do. Come on. This thing is too heavy here. Aha! Alright, now it wanted. But I have a little bit here left. Okay then, I can do it. I can do a compromise probably. Between the two. Like that. Well. Shit! Yeah, you know what? You know what? I can do something else actually. I can put this thing here. Like that. Excellent. This is what I wanted. This is what I wanted. Okay, good enough. Good enough. Like this. Perfect. Yeah, quite a little bit of trouble here, but in the end it worked. And this one, this is the hardest actually, to mount it and to wire it. So I will have to think hard how I will do it. You know what? I have an idea. I have a very interesting idea actually. I can push it through that hole, but with isolation wire. This means a very large hole somewhere there, but the wires will be isolated that will come out of there. And long enough they will be. Probably these two wires are good enough. Another idea I was having was to insert this here inside it, because I do have some space. but because I glued everything, I was thinking before gluing to insert it inside, but I said I will find a way here on the top, or probably like this. Like this. It's looking as strange as fuck, but it's nice. It's nice. I like it. So the wires will go here somewhere, and it's perfect here. So I need something to catch it, to hold it at least. What it can be? Yeah, let me think about it, and I will film it, and I will show you later after. I hope you liked the evolution until here. Very nice, very compact, right? All right, leave a like. So this is my solution. I bent the legs like this and like this, and from this side like this, you see, and I unite them together, and they will fit into that little hole there, you see. And then I will not drag the wires from this side, but instead I will make two little holes, one here and one here, with a 3mm drill, and I will insert the wires from this side, and hopefully I can take them, catch them there inside, and drag them out, and then solder here from the wires this little thing, push it down, and drag these wires further out. That's the plan. But we will see. I managed to make a hole there right in the middle here, and if we are looking on the circuit, the buzzer, it needs 5 volts here, and the other wire is going to the second output. So I'm having already 5 volts here, so I can drag this wire here directly, and I make it long enough for the buzzer to stay in air a little bit, and I will drag it underneath here, and I made a hole, one single hole here for the other wire that will come through inside and then exiting from here and then going there. That's the plan. This was the most tricky and hard to mount, especially here in the front. So that's the positive. Actually, I will not catch it right now. I'll have to drag it first through this hole, because it's a little bit hard, but once it's getting through that, not this end, I want this other end, motherfucker. Yeah, good, easy. So you see, on this side here, I can link it to this 5 volts that is very close here. That's why it's good to have little notes. What is everything? Plus 5 volts, pin 7, ground. This little details is helping you along the way when shit goes complicated. So you see, I have a lot of space here, and I can push this wire inside or leave it like this. Yeah, I can drag the wire from this side, and now this wire here. Now let's insert it here, and hopefully I will be able to drag it, to catch it and drag it from this other side. I don't think so. Probably, you know what, I will have to enlarge that hole to leave more room to bend more easily. Although I like it as it is right now, small, only for this wire to get into it. Come on, a catch, you know, like a hook, a mini hook to hook this. Yeah, I can see it very close here. Excellent. I'm very glad I didn't have to enlarge that hole. Yeah, it was tricky, very tricky. All right, this is it. Nice, very nice. It is so goddamn loud. I can actually add a small resistor to it to tweak its volume. So what I said was that I will drag this wire from this side like this. Yeah, see, and this as well, until I will fit it there. Very, very tricky. Good. This is it. This is what I wanted. It's good. Okay. And this wire. Holy fuck, this was the hardest. And this wire is going to the output of the second, which is here. This is the output of the second here. Everything is crossed like that, and I don't like it, but well, actually I can leave this very long wire like this. Like that. It's literally circling all the circuit, but it's not that neat, but 1 or 2 wires like that is not the end of the world. Yeah, pretty interesting, right? So I'll have to add the power wires. This one. This is the antenna. Okay, let me change the power wires with longer, with this ones probably. Okay, good enough. Like that. And the needle is moving like crazy here. You see where it is? I hope you can see it. Nice, very nice. Yeah, this is super loud. Let me put this. The needle is moving exceptionally from one end to one end. Very good. Very good. Yeah, do you like it? I like it. And look at the range. Fantastic range. Fantastic range. Wise. Yeah, fantastic. Good. Very good. Yeah, very nice. I really like it. I really like it. And that's it pretty much for the circuit and the assembling of it. And now to make a box for protection, and I have no idea how to make that box. And I'm thinking a little cardboard that I will glue here or even here for the power wires to link them more easily, not in the circuit like it is right now. Is working very nice. A bit complicated, but it turned out very well. Very nice. I have no idea what to measure with it, but it's looking strange and sophisticated, you know. And this is good for a prank, probably. If you want to prank someone, to verify its badness, how bad that person is, it will tell you how bad it is. Very bad. Or, you know, like a radiation signal. Yeah, very cool, very cool. Let me close the lights to see the LED, how bright it really is. It's really bright. But usually I'm seeing it from this side, from the front, you know, not from the top. And you can see it's lighting up, especially there. Very nice. The needle is moving exceptionally nice. Yeah, from a scrap, literally it was a scrap coil meter, repaired and actually made a project with it. Probably my hand is influencing how the sensitivity, but it's very sensitive for a very good range. Very cool, very cool. It's a toy, it's a nice toy. Yeah, it's having this little bug when it's beeping like an idiot, like this, like I am touching the wire, you know. But yeah, here on the table probably is not that sensitive for some reason. Interesting. But in air is working fine. I really like the needle travel. It's fantastic. Fantastic good. Why is this much? I have no idea. If you remember in tests, it was staying on the middle there all the time on that breadboard. Yeah, very cool. Very cool. Okay, that's it. I hope you like it. And also leave a like. Like I said, I have to add the box. And the project is fully, and probably a handle of some sort. Or here, like this, you know. You see? Like a handle. And this antenna, I don't know, to move it there. Somewhere. I don't know. But it's a cute and nice project. It's a cute and weird project. And I like it. I actually like cute and weird projects like this. Alright, bye bye. See you next time from your favorite artist electronist, Mr. Q12. Ha. Alright, I managed to make a case, if you want to say it is. So it's fitting like this, see? I have some room here for this capacitor and some room for this transistor here, you see? And here I will put some scotch, here and that's it. And it will be protected good enough. I also changed the antenna position and also the power wires. And pretty much this is it. Yeah, it's a cheap, very cheap and dirty solution for the case, but it is doing its job. It is protecting what's inside, and I can put it on this side with the circuit without being worried about damaging it. Let's hope this scotch is good enough. Okay, it's looking good. All right. Okay. And that's it. It's this simple and very easy to take it out and put it back with the help of scotch. So right now, this is the final version actually, with the case, with everything. And the needle is moving nicely. and I'm having a very large range. A very large range of operation, of movement. Yeah, very nice. Let's see, like this. I hope you can see the needle that is moving there. Very nice, very nice. Very, very nice. Yeah, it's better in air to hold it. Yeah, very cute, very nice. Finito, this is finished. And it's very compact, it's very cute, and it's finished. Yeah, on the table is not that sensitive for some reason, but in air it's very sensitive. Yeah, and it's probably getting in error mode a little bit more quickly. I'm putting a little bit of glue here for this piece of paper to be stick here. Yeah, good. Because it's way too strident, it's way too loud. And you can hear it good enough. Very cute. I like it. I like it. Yeah, unfortunately, it's more like a toy than anything else. I hope I can use it somewhere in the future for something else. Here is not doing the error, but sometimes it's doing it. And probably is that capacitor is one of these capacitors here. Probably I should change this and this a little bit, but it's good as it is. After all, I literally have no idea what to use it for, other than you know, like a little toy. Yeah, this is it. Thank you very, very much for watching and for staying so long. And also press the like button. And see you next time to the next adventures. Bye bye from my favorite artist electronics, Mr. Q12. Bye bye. Alright, and here is the circuit. This is actually my very first circuit that I tried, and it was giving me this chirping sound like a bird, like, and yeah, it wasn't what I really wanted. And after that, I made this one with PWM, and it didn't work very well. You see those notations I put. And this is the actual version 1. It had a ton of problems. And this is what I used in my very first movie. And this is version 2, coil meter needle range improved, signal amplified. When I added this transistor here, when I figured it out that I should change perspective of this MOSFET sensing element and use it exclusively as a sensor, and this GPT or general purpose transistor here to use it as an amplifier. So this pretty much showed me the way. After this point, after this version, I just updated it, improved it, tested until it worked. And this is version 3 simplified. In version 2, I was getting stuck with this LM358, and my intention was to use it as an amplifier plus this transistor as well. So this section was the amplifier section. Amplifier for it was amplifying and cleaning the signal that was coming from the output, because I showed you in my previous movies. So this is how the signal is actually coming from pin tray of this 555, very, very sharp spikes. So that's what this amplifier is doing, is cleaning and amplifying probably that very sharp spikes. And the role of this NOT gate, well, the first NOT gate is to inverse that signal from, as you can see here is positive, and the spikes are towards the negative, but this NOT gate is inversing from everything on negative on 0 volts, and the spikes are towards positive 5 volts for everything to work and to show correctly, the LED to show correctly, to stay off and to lit on only when the spike is happening, and this coil meter to move its needle, and also the buzzer to be able to buzz correctly. Although it is working correctly only here in this circumstance. Let's see if I change it here. Yeah, I did change it. I put it from positive here to this negative. It works. So this is this version 3 is simplified without this op-amp when I get rid of it, and I simplified the circuit. And here, this is the last version, version 4, when I actually changed the LED position from how it was before. It was linked in series with the coil, and all these versions, in the previous versions, as you can see, it was dependent. in that position. I didn't think of it. I just leave it because it worked. But then I got a little bit more courageous and I switch it, and it did work here and also here on the emitter on this line. I put it also to the ground. It was working also. So this is the most updated circuit, the one that I actually mounted into the case. I've included these two capacitors here over the input and the output of the NOT gate because I had some beeping problems for the buzzer. The buzzer was beeping continuously, and I believe the LED was staying lit all the time as well. So this secondary capacitor most probably was because of this very long line was catching interferences, and those interferences are very, very similar with these spikes. Most probably this is how I'm imagining them. And probably this cleaned some percentage of transients and it left only the signal, but the signal is having a little bit of problem. Sometimes it's beeping, it's having a little bit of errors sometimes, and it's not perfect, but it can be perfected more than it is. This is the recipe, and if you want to improve it more, just change some values wherever you feel like it, and play with the circuit and see for yourself if you want to build such a thing. It's an interesting device, and is an interesting toy, and is also an interesting circuit for the application of the MOSFET to actually see. With this project that I built here, I'm actually showing sensitive the gate of this particular MOSFET 2N7002 is. So it's extremely sensitive, is way out there, way out there, way too sensitive for my likings. And this is very good as a sensor. You know, this type of MOSFET, how sensitive it is very good as a sensor in itself. All that you have to take care is not to touch the wire ESD, electrostatic potential or discharge, into the gate. And if you are careful, it's good enough. You know, you can play with it. Just keep in mind that it's extremely sensitive and very fragile. If you breathe, literally, if you breathe hard over its gate, it will get destroyed. I'm not kidding. I'm not kidding. It's that sensitive. This is a particular motherfucker. This is not the same for every MOSFET out there, but this only for this one in particular, that I put my eyes on it because it's interesting. You know, I find it very interesting. Okay, this is it. This is all the circuit. This is the final circuit that you are seeing here, this version 4, and that's it. Thank you very much. Bye bye.